Okay. Number 5, the only thing that we're changing is I'm giving you a force of friction here. So the rest of the problem is the same, we just now have some friction. I'm telling you the coefficient of friction, and so I'm not directly telling you what the force of friction is in this problem. Can I straighten it out anymore? See me a little bit better if I do this. Alright, close enough. So you can still find it. You can still find it. I'm giving you the coefficient of friction here, but now in number 4, I told you we didn't have to do anything with normal force. Well, since the force of friction is equal to normal force times coefficient of friction, now you need that. So now, in the last problem, you found x here. We had to use that the sine of 25 degrees times the force due to gravity is equal to that x part, right? Because x is opposite the 25 degrees here. So now, if I'm going to find my normal force, do you remember last time I was saying that this component and the normal force have to be equal and opposite because this is an equilibrium in the y direction? Okay, so now I have to figure out this component of my force due to gravity, of my Fg, in order to find out what this is, because this will just be opposite. So then, if y is adjacent to the 25, we know we can use cosine here. So that means cosine of 25 degrees is equal to adjacent, which is my force due to gravity in the y direction only, divided by my force due to gravity. So that means y is equal to force due to gravity times cosine of 25 degrees. So if you have this y, then we know, remember that since this is acting in quadrant 4, x is positive but y is negative, so that's going to be negative whatever this value is. I'm not going to calculate it for you. That number then, as a positive number, is going to be my normal force. So once I calculate my normal force, then I can calculate my force due to friction, because that's going to be normal force times the coefficient due to friction, or the coefficient of friction, mu k, which I gave you in the problem. It's 0.15. So you've got that. If I know the weight of the little girl, or the child and the sled together are 45 kilograms, so if I want to find their weight, their Fg, it's just mass times acceleration due to gravity. Then I can break that up into my x and y components. I can find my normal force. I can find this force. The reason that I have to do that now is because the sum of the forces in my x direction are going to be equal to this force of the weight in the x direction plus my force of friction. If that's acting this direction up the hill, I'm defining that as being in the negative direction here. Positive going down, negative going up, positive going up, negative going down, always just like your regular coordinate system. So that means that the two forces that are acting in the x direction are Fg in the x direction, so that's this component right here, plus my force of kinetic friction, which is this component right here, and remember that is a negative number because it's acting this direction. It's going in the negative direction. Okay, you should still then be able to find the acceleration. Remember, once you find the sum of these forces here, remember that the sum of the forces in the x direction are equal to mass times acceleration in the x direction. And for 4 and 5, that's what you're solving for. That's the final answer, is this acceleration, okay? That's not just for this problem, but also for 4. You got it? Hopefully. We're starting to get a little bit more challenging here. If you do have questions, it's okay to save them for me. But I really think with the work that we've done in class together on other vector problems and other force problems, you guys can bring those together and do this. Synthesis.